welcome back to Wisdom Window for another segment. So in our last video, we talked about how to find the area of a shaded object. Do you remember that? We used our knowledge of the distributive property and also other formulas and strategies for solving area. So before we learn something new today, I would like us to review our vocabulary so we keep that fresh in our brain and then move on to some new vocabulary as well. All right, let's check it out. So remember that area is the measure of space inside of shape. So instead of looking at that perimeter or the fence line, we're looking at the inside of a shape. And then a square unit is what is used to measure the area of that shape, whether it's inches, centimeters, meters, feet, yards, you name it. And that leads us into what we learned about standard units. We learned about customary and metric units. Remember, customary is what we use here in the United States, and that includes inches, feet, yards, and miles. And then for metric units, that's what like Europe and the rest of the world uses, and that includes meters, kilometers, and centimeters. And then we have the distributive property. This is something newer that we learned, and that's when we looked at the area of a figure. We looked at the length, and then there were two widths, and so we used the distributive property to measure the length times a width, the length times a width, and then add all of those together to find the area of the entire figure. And then we used this information from the distributive property to help us in better understanding how to solve for area of a shaded figure. Okay, and now since we have refreshed our memory on what we have learned about area, let's learn something new. So our new vocabulary for this segment is irregular shapes. Now what are irregular shapes? Well, those are polygons with 5 or more sides, and they have varying lengths. So kind of like these examples here. So it's not like a square or an equilateral triangle. You've got an isosceles triangle here, and you've got some other figures here that don't look regular, right? They're irregular shapes. So now we're going to use this newfound information about irregular shapes to help us learn how to find the area of shapes like these. It's a little trickier, so I'd like you to really pay attention and make sure you're grasping this information. We're going to go over some steps first, and then we're going to go over some practice problems in the workbook. That way you can build a strong foundation and be able to work on these on your own. All right, let's go over some steps. Step 1. We're going to count the number of whole squares. Step 2. We're going to count the number of partial squares. Step 3. We're going to estimate how many partial squares equal one whole square. Step 4. And we're going to add our whole and partial squares to find the area. And then we're going to write our answer using square units. So now since we know the steps to take in order to find the area of irregular shapes, let's go into our workbook page and solve some more practice problems. All right, let's go. All right, so now we're all ready to start our workbook page. We're on 14-7, and that's the area of irregular shapes workbook page. So our directions read, find the area of each shape. Together, we're going to go over numbers 1, 3, and 5. And now if you look on the bottom of our page, number 8, I want you to give that problem a little circle there, and I'm going to tell you that you can skip this problem. Just skip it. I think this might be a little too tricky right now, but if you're ready for the challenge and if you want to try it, feel free to use this problem as a challenge problem. Other than that, I would like you to skip this problem. Okay, so now if we look at number 1, we see a 4-sided shape, and that one is an irregular shape. So we're going to find the area of it using the steps that we have learned so far. So our first step is that we need to count the number of whole squares. Can you see the number of whole squares? Yep, I can too. So I'm going to label those. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we have a total of 10 whole squares. So I'm going to write whole square and just write 10 so I can remember. Okay, and then our next step is that we are going to count the number of partial squares. So let's see what we have. We have 1, 2, 3, 4, 5, 6, 7, oop, there's a little one there, 8, 9, 10, 11, 12, 13. Okay, so I'm going to write partial $13. Okay, so now our step 3 is we're going to estimate the number of partial squares. So by estimating, you're just going to be looking at all these different partial shapes and see which of them can combine together to make a whole square. So let's see. If we look at our biggest squares first, because I feel like that's the easiest ones to work with, we have a pretty good sized square there. And then we have a little sliver of a partial square right here. So I'm going to say that those two equal 1 square. I'm just going to fill it in just so I remember that I counted it. So we have 1. And then I'm going to look around. Oh, I see this square. This square is almost done. And look, there's a little corner right there. So I'm just going to shade that in and call it 1 square. Remember, we're estimating, so we're just kind of guessing of what would make a whole shape. So don't take too much time trying to figure this out. And don't stress about it. This is just kind of one of those things that you just have to just roll with it. So let's see. Let's see if we can find another one. Let's see. Okay. I noticed that these two kind of look similar, or like a half almost. Don't they look kind of like a half of a square? Yeah, I agree. So I'm just gonna estimate and say that that's a square. Yeah. Right there, there's a square. Okay. And then, I'm going to say that this one kind of looks like a half too. Or maybe it looks closer to something. This is difficult. I can estimate that these two would make a whole. Right? Okay, so now we have 4. And then I'm going to just say that this one and this one make a whole. I'm just estimating. We have 5. And you know what? These are pretty big, so I'm just going to have to say that it would make 1 square. There's not a way to complete 2. So I'm just going to leave it as 6. So now that's my estimated whole squares out of the partial squares. Like I said, you can do it many different ways. You can shade it in, you can count them, you can number them off. It is completely up to you and what you prefer. So now we are going to go on to our last step, and that is to add the whole and partial squares to find the area. So let's see, we have 6 here. So we have a whole number of 10 and then a partial wholes of 6. So we're going to add 10 plus 6. What's 10 plus 6? Exactly 16. Okay, so we're going to write 16 on our line. And it says in our steps to also write in square units. And usually we'll write it like this. We'll write 16 square units. But did you know that there's another way to write this? It's in simplified form. Yeah, you can write it like this. You can write 16 units and then with a little 2 above the units. And that also means square units or units squared. So that means it's squared. Kinda cool. So then that's how we're gonna write our answers for this worksheet. We're gonna write units, and then we're gonna add a 2 up on top right there, okay? All right, let's practice another one. And I know this is a tricky lesson, so just hang on. So our first step is we're gonna count the number of whole squares. So let's count the number of whole squares first. So let's see, we have, okay, there's 1, that's a whole square. And then we have 2. And that actually looks like that's it. So we have 2 whole squares. And now let's see, we're gonna look at partial squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 partial squares that we need to figure out how to make whole. So we can do this by just looking at the different sizes of each shape or each of the partial squares, and to figure out how we can kind of puzzle those together in order to make a whole square. So once again, we're just going to continue our estimation. So I'm going to say that this square, or partial square, plus this partial square equals 1. And then I'm going to say that this partial square plus this partial square is also 1. And then, let's see. Yeah, I think we're just going to continue with this. This square, partial square is equal. This partial square is another 1. And then this partial square and that partial square can make a whole. And then let's see, so we have almost a hole in a corner, almost a hole in a corner. So I'm just going to say that that makes a hole. Like I'm just estimating, so it's up to you if you agree. Okay, so I'm gonna say that I found 6 again. And so now in our last step, we're going to add our whole number of squares and our partial whole number of squares. So we are going to have 6 plus 2. And 6 plus 2 is 8. So we're going to write an 8 in our line, and then instead of writing square units, we now know that we can also write units squared in short. So we're going to write units square. If you prefer to write square units, you can still do that, but now you know that you can also write that as well. Okay, let's go over one last problem. So for number 5, let's review our steps. What is my first step that I need to do in order to find the area of an irregular shape? Good. Okay, so we need to find the total number of whole squares. So we're going to count them. So we have, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we have 10 whole squares. And now we're going to look at these partial squares and find out the ones that would make a whole square. So actually, this one's going to be fairly simple. See how it's divided right down the middle of each square? So we know that 2 halves equal a whole. So this half plus this half equal 1, and this half plus this half equal a whole, and then this half plus this half equals a whole, and same with this one. We have a half, and that equals another whole. So now, what is our last step? Yep, okay, we're gonna add up the whole number of squares, and we're gonna add it to the partial wholes of squares. So we have 10 plus 4. What is 10 plus 4? Good, 14. So we're going to write 14 on our line, and then we can either write square units or units squared, but I'm going to write units squared. All right, and then so for the rest of these problems, you're just going to go through, you're going to first count the number of whole squares, then you're going to count the number of partial squares, then you're going to estimate how many partial squares equal one whole square. And then lastly, you're going to add the partial squares and the whole squares to find the area. And then you're going to complete your answer by writing either square units or units squared. And just remember to skip number 8 unless you want the challenge. All right, so that was a pretty good challenge, right? Irregular shapes definitely gave us a good challenge. But now since we know the steps of how to find the area of an irregular shape, hopefully you feel more confident in solving problems like these. Once again, you can skip that last problem because that one's super tricky. However, if you want that challenge, feel free to go for it. I encourage you to have a challenge. If you still feel like you're struggling with this lesson, please let me know. You can write to me in the comment section, or you can tell me on Zoom or in the comments in Zoom. I'm there to help you no matter what. But in saying so, I am so proud of you guys for hanging on. This was kind of a tricky lesson with a good challenge, so I'm really proud of you guys. And now I have some trivia for you. I have an answer from our last lesson, and then I have a new question for you. So my last question was, in what U.S. state was the Civil War Battle of Gettysburg fought? So what state was it fought in? So the answer is Pennsylvania. Pretty cool. A little history trivia for you. All right, and now I have a new question for you that I'll give you an answer for next week. And that is, what is 309 rounded to the nearest 100? All right, well, you'll find out the answer next time. Until then, I'm so proud of you. Thank you for tuning in to yet another segment, and I will see you in the next video.